This is problem 30, uh, extended response or constructed response on subtest 2 for the CSET. All right, and in this question, it says housing units in the U.S. So we're in 1999 were distributed as follows. So 69.1% for the owners, occupied 24.56%, renter occupied, and 6.3 were vacant. Researchers wishing to determine this value, a random sample of 500 current housing and found that 375 owner were occupied and there were 125. Okay. So the first part is state the null hypothesis that the researchers should use to determine whether this data suggests that the distribution of current year-round housing differs from the 1999 distribution. And then the second part is based on the 99 distribution, determine the number of housing units out of sample of 500 expected to be owner occupied, renter occupied, and vacant, determine the value of the chi-square test of these sample data. And then the table below corresponds to a distribution of 2 degrees of freedom. Use the table to determine if the 5% significance level, at the 5% significance level, the data suggested. Okay, so this basically walks us through how to do this problem or what we're supposed to do for this problem. Okay, so I think it's helpful when you're doing problems like this to kind of like think of it in a tabular form. Okay, so if you're first of all, the degrees of freedom. So this is a chi-squared test with 2 degrees of freedom. That's because we're looking at three categories, right? We have the what do they call it? The renter occupied, the vacant, and the owner. Um, so yeah, let's go ahead and write those out. So we have owner, and then we have owner occupied, I guess is the full term. Owner occupied. I feel like I misspelled occupied. No, that's right. Okay, owner occupied. We had, what was the other one? Renter occupied. And then was it vacant? Yeah, vacant. Okay. I forgot the end. Vacant. Okay. So that's kind of the so we had 1999 values, and then current, or I'll say now. Okay. All right. So here is our table based on the data. So in 1999, what did they have? They had 69.1 over 100 times 500. That will equal the observed or the expected amount, right? And then you had 24.6 over 100 times 500. Okay, and then you had 6.3 divided by 100 times 500. Okay. So we'll need to calculate each of those values. And now the observed values were for owner occupied. We had owner occupied. In this current sample of housing, we had 375 in the owner occupied. We had 100 in the rented occupied, and we had 25 vacant units. Okay, so let's go ahead and calculate those. And so calculating these out, this is 0.5. So we have that our expected values would be 345.5, 123, and 31.5. Okay, and so we're going to use a chi-square statistic. So we're going to calculate that next. And so the chi-square, I feel like I should maybe write it over here, is the sum of the observed minus expected squared divided by the expected. Okay, so you sum over these values. So for us, we're going to have from I equals 1 to 3. And so that's going to be the chi squared statistic for this with the 2 degrees of freedom. Okay. So that means we'll take the difference of these two and then divide by the expected value here. So I'll write that out, calculate it in just a second. So, and part of the reason why I like doing the table like this is that it kind of helps me to keep everything organized. So I'm going to make the 3 here and then subtract. So 375 minus 345.5 squared over 345.5. Okay. I have 100 minus 123 squared over 123. And then I have 25 minus 31.5 squared over 31.5. Okay, so I'm going to calculate those out and add each of these three results together, and that will be my the value that I'm looking for. Okay. So plugging in the numbers, I'm getting this is 2.51, this is 4.30, and this is 1.34. And if I add those all up, I get that the chi-square value is, this is my chi-square of 2 value, is equal to 8.16. Okay, so so we calculated the chi-square, but we haven't discussed what the null hypothesis is and all of that. So let's go back and do that before we interpret what this means. Okay. So if you look here, right, and the problem is saying that in 1999 they were distributed. They found that these were distributed as follows, and then they did some investigations, and they found that these were the numbers that were there. So the null hypothesis then for this one, so H naught is going to be there is no difference in the observed versus expected values of um, of occupied by housing. Okay, so there's no difference in there is no difference in the observed versus expected values of occupied housing between 1999 and now. Okay, so that's our null hypothesis, is assume that there is no difference between the two. Sorry, it's kind of crunched in there. Okay. So your alternative hypothesis is that it's the same idea, but you would just say that there is a difference. And I will not try to squeeze all of that in here, but you would say essentially exactly the same thing. There is a difference in the observed versus expected values of occupied housing between 1999 and now, would be your alternative hypothesis. Okay. So we need to construct the chi-squared value, which we did down here, to determine way down here. So this is our chi-squared value. So we need to determine if this chi-squared value is significant enough that we can either reject the null hypothesis, or whether or not we have enough information to reject the null hypothesis at this significance level. Okay. So this table is for 2 degrees of freedom, and we have 2 degrees of freedom with this chi-squared, the 2 degrees being 1 degree less than the number of observations that we have, right, or variables that we have. Okay, so if we look, where does our 8.16 value fall in between? Well, it's bigger than that. It's bigger than that. So it's bigger than this, but it's smaller than this. So our chi-squared value is somewhere in here. Okay, which means that our p-value is somewhere in between these values. Okay, so our p-value is between 0.025 and 0.01. Okay, so that's our p-value. It's somewhere in between those. Well, even at its biggest, even if it was equal to 0.01, that's still significantly less than, which is less than 0.05, which is the p-value that we would need to have our p-value less than in order to reject the null. And since our p-value is significantly less than that, okay, then we can conclude, so 0.025 is less than P, which is less than 0.01, which P is much less than 0.05. The double means it's much less than 0.05. We have enough evidence to reject the null hypothesis. And you could say something like it at the value of that. But since the p-value is significantly less than, that means that there is most likely a difference that is related to the observed and expected values between the types of housing value or occupied housing structures that are there. Meaning that it's very unlikely that this just happened by chance, that there's some other cause that is causing the difference in the observed and expected values. Okay. All right. I hope that was helpful, and I'll see you in the next video.